Hey, what's up and how's it going? This is Toby, and in today's video I want to show you all how I created this little AR game prototype here for Snapchat using Lens Studio. And as you can see, in this game your objective is to simply cross the street. And today I want to do things a little bit differently. Instead of going through everything step by step, I rather want to jump into the finished project and kind of lead you through all the things that I've done and actually why I've done them that way. And of course I'm gonna provide you with all the important resources in the video description. So please let me know in the comments what you think about this kind of new approach to the tutorials, and without any further ado, let's get started. Alright, so here we are in the final Lens Studio project, and of course first of all I started by creating just a standard default project when opening up Lens Studio. And then in order to get augmented reality running, you're actually gonna go to your camera and then add device tracking and set the tracking world to mode. So this is actually the first thing that you gotta do so that your camera has some kind of world understanding and also create some kind of depth understanding for the scene. And then I also wanted to create meshing so that we would be able to actually place our AR scene so that it wouldn't be somewhere floating around here in the beginning. So for that I created a AR world mesh, and you can do that here in the asset browser by creating a world mesh and then also adding the world mesh component here into your scene. And then this will create a meshing effect. So I also added the matte shadow material, which you can also add in the asset browser and drag it in here. But if we would switch this out with some other material, let's take for example the world mesh material here, then we can see that this is actually what it looks like. So if we're gonna reset here our scene, we basically have some kind of live meshing going on. So there's basically the scene understanding. And then if we click somewhere, we actually got the AR scene being placed at that position. And yeah, kind of things are getting started. So let's switch this one back to the matte shadow. And this way it will only actually cast shadows. So this was basically the AR scene setup that you pretty much have to do anytime you want to play something in augmented reality. And then I actually went ahead and created kind of the game logic that we would need. And for that, I begin always by, so let's quickly turn the place all objects logic off. So this is the script which will place down all the objects. So if we remove that, we can see that we basically have our scene going on here. And we can also move this a bit in the scene editor here. So if we take that and just move it a bit, let's say forward and to the side like that. Yeah, so we have it somewhere more in the middle of the scene. All right, so this is the general game logic that we got running around here. And so the way I approached this was, first of all, I wanted to have basically one street with a car driving from one way to the other, and then also have the collision working with, for example, a character. And for that, I definitely, first of all, needed some 3D objects. And actually, Lens Studio has a quite good asset library. So if we click here on 3D, we do have some kind of assets going on here, some characters. And also if we scroll down, some basic stuff. For example, there are some cars here and some, yeah, for example, here's a retro car that we could take. And there's also some kind of city pack, I guess. I found it somewhere very much at the bottom. Yeah, for example, here's the vehicle pack, and I basically took the red car. However, there's also a new Gen AI function here in Lens Studio, which allows you to basically do 3D asset generation. So if you click on here, you can go ahead and enter a prompt. For example, you can say, you know, a red car or a yellow car. And then you also can add image references or negative prompts or things you don't want. And then we'll create these 3D models. And although they, of course, don't look perfect, especially for like prototyping, they're pretty great. And also if you don't need some kind of animation, So these are not animated, right? That means we can just use them as they are. And for example, the character I actually took from Sketchfab. So I went to sketchfab.com and entered some kind of character and clicked on downloadable and animated. Yeah, and somewhere found the panda character here. You always got to be careful though that if you download and use the characters here, then there shouldn't be too big in file size. So for example, this is 40 megabytes. This is way too big. I think our whole effect in Lens Studio can be, I guess, 8 megabytes. Now we actually have to click here on the project settings, and then we can see that our lens size can be a max of 8 megabytes, with also an additional 10 megabytes for Snap ML, which would be the kind of machine learning stuff and AI stuff. So we're already here at 4 megabytes, which is half of the effect. And this is already, I'd guess, on the larger size. So we really got to be careful here with 3D objects. Yeah, so then back to the workspace. I imported these models here into the Lens Studio project. And if you click on them here, for example, you can see that, here's the car. Let's actually set the position here to 0, 0, 0. What I actually did here is I added some kind of collider, and we can see that it's a bit below the car here. So let's actually increase it a little bit here. And this one is going to basically then collide with our panda character, so with the character that is moving across the street. And then I also basically did the same thing for the other two cars, so just imported them, double-clicked, and then added the physics collider component. And I also created a script which I called the car looper, and once again all the resources are in the video description. So if we click on that, we can see that this is a pretty simple script which takes a scale and drive duration as input parameters. And it basically in the beginning here gets the original position of the car and the original scale, and then we'll have a goal position, start position, timer, and a state. And then through the API, which allows you to call functions from different scripts or from behavioral scripts, for example, I created the run function, which has a goal. So basically what happens here is we're going to call the run function, and we're going to set the goal position to something that we pass into the function. And then essentially, we're going to start with our update event with the state 0. So we're going to initialize the state 3, and we're going to set here at the run function our state to 0. And once that is done, basically the car is going to first of all scale in. So it will set its scale to 0, and then it's going to do a lerp from 0 to the original scale. Then it's gonna set the state to 1, and state 1 means drive. So it will basically then lerp from the start position to the goal position. So this is kind of the driving interpolation here. And then finally, in state 2, we're gonna once again scale from the current position to 0. So then if we go back to our scene, which we can do by double-clicking on the scene object in the asset browser and go back to our preview, we can see that I actually created originally a empty object here. So this is under or an empty scene object under the general tab, so it's easier kind of to organize. Then I went ahead and actually created 3 planes. So these are the street components. So I actually went ahead and just clicked on the plus, entered plane, and then added a texture. So this texture I think I even created with ChatGPT. You could also do that here in the Gen AI stuff. Creating a texture, probably say street texture, I guess, and then just generate and use this with a material. So I then went ahead and created a new material. I think we actually want to create some kind of either a simple PBR or unlit material. So we could call this simple street. And then just use basically a texture. So yeah, so this doesn't look too good. So let's actually call this one stylized street. Maybe you want to call this stylized road. So let's rather use the texture that I created earlier. So this one was using, again, ChatGPT. So we could just drag that into the base texture, and now we would have a street. And we could also change the roughness and metallic values here to have it more actually street-like. And then I simply applied this here, well, to the planes so that we would have a street. And I took 3 planes to have, you know, enough space for the street. So then I also created a lane spawner script. So let's quickly have a look here in our script editor. So the lane spawner. And so this one is actually quite simple. All it does is it takes a array of objects that we would drag in, and this would be our cars. Then it has a minimum delay, a maximum delay, so basically a random delay in which the cars are spawned, and also has kind of a goal object, so where they should essentially drive. And then first of all, we want to kind of instantiate the cars, and so first of all, the script is going to instantiate the cars and make them invisible or disable them, essentially. And then it's also going to get the script components, which is the car looper from each of these cars. And then all we do is essentially in the update event, we kind of gonna get a random delay. So we have the next delay here. And then we are going to spawn the cars. One after another with a little bit of delay in between. And in order to be more efficient, we are not simply going to newly instantiate the cars, but we do have a pool, which is going to be like 5 or 6 cars, 2 of each kind. And then they're going to be activated. And then we are essentially calling the car looper script here because we are saving this as the driver variable. So we are basically pushing an JavaScript object or JSON object to our pool, which has the prefab, the instance, and the driver. And essentially, once we're going to start with the spawning, we want to trigger the script by first of all setting the object active and then just calling the method here with the goal object. And so what that's going to do essentially is in each of our streets here is going to take the first car. So you see that I do have each car here twice. It's going to take the first car, is going to enable it. So first it will, of course, instantiate all these cars, disable them. Then it's going to take the first car, enable it, will then make it drive to a goal object, which is essentially just a empty scene object, which we've already created earlier here in the general tab. And it's going to be set somewhere at the end of the street. And it's then essentially enabling the car, setting the goal here, and then waiting for the delay to send the next car. And so then the car is going to drive to the goal, going to scale down. And after the final car has been spawned, it's going to then again take the first car and going to run the script once again. And so that's why it's quite important to have enough cars here in the pool. If we only had one car for each type, then maybe it would send the first car already on a new trip, if you want to say so, despite it hasn't already reached the goal, which would be suboptimal. So then for the character, I actually got a random character from Sketchfab, which was already animated. And I then added the physics body component. We actually don't need the physics collider here. And then I also had to add a physics world setting to disable the gravity. So you can do that in the asset browser by adding the physics world settings. And it's going to pop up somewhere, I guess, in the asset browser. Let's see. And here, for example, you can simply disable the gravity. And this means if you now would drag this into the physics body of the character, that it wouldn't just fall down because of gravity, even though there's no kind of plane under the area here. But still we would get the benefit of that when it gets hit by a car, it will still kind of fly away, which is a pretty good physics effect to have. And then, of course, you can also show the collider and then kind of adjust the visual type of the collider. Sadly, you're not able to move it up or down independent of the character, I guess, independent of the visual. So I was okay with having just a little sphere collider here at the bottom. And so that was enough to get me kind of the physics effect that would happen when it would hit a car. So then within the character, we also have a character controller script. And here I actually also experimented a little bit. So we also do have kind of a state machine and some variables that specify is the character moving, that, or do we one, for example. And we also have kind of animation clips saved here, right? So if we, for example, import a character into Lens Studio, such as this panda here, which does have animations attached, we will get kind of this animation state or animation player component here. And these are all the animations. So this all already came with the character. So it does have, for example, sitting, attack, greet, sleeping, and whatever animations here. And so then if you kind of want to trigger those, you can go ahead and reference the animation player as well as the walk animation or maybe die animation here in the script, and also attach those in the inspector. So here we do have the animation player as well as the walk and die animation. And then simply drag those in. And for example, then we do have some exposed functions here, for example, the move forward function. So if you want to, again, call a function from a different script, you can write script dot and then some name equals to a certain function inside of your script. And then you can basically call those from either behavior scripts or just different scripts. As we already saw here with our lane spawner. So essentially, we're gonna get, for example, the script component here, which is the car looper. And then in the car looper, we're just gonna call the function. So this one is called run. And we are also saving the function here under run. So here we have the run function that we are calling. So back to the character controller, we will actually then, for example, go through the animation player, so script animation player, and then we can add or play a clip. For example, we can play the die clip that we do have here, and this will just trigger the animation on the character. And I've been also experimenting a bit with buttons. So I actually did have some buttons here on screen where you could click and move the character forward and backward. But then I decided that it would just be easier to just have move forward on simple screen tapping. And for that, so we do have the begin move function, right, which is triggered by the move forward API, you could say so. And all it does basically is then on the update event, so each frame it will essentially check whether it is actually moving. And at the same time, we are using actually some overlap and collision triggers. So we do have the on collision enter and on overlap enter to either check whether we reach the goal, so then we won, or whether we have an actual collision and then we die. And so these will work with the physics body components. So this is attached to the player as well as to the cars, as we saw a minute ago. And so if two tangible objects collide, basically, then it's going to trigger the on collision. And if one of these objects is intangible, then it's essentially triggering the overlap. So for example, if we go back here into our scene view and we're gonna show the AR scene. So let's take a look. We do have here the goal object, so the finish object, and this has a physics body attached, which is intangible, which means that if our character runs against the finish line, it's essentially just triggering the on overlap, which is this method here. So then we also have our mission win script attached here and mission fail script. So essentially once a collision or an overlap happens, then we have our mission fail logic, which is simply going here into our 2D full frame screen view essentially. So we can watch that by opening up the 2D scene view here like this. And so essentially this would just show game over or you won. And all I essentially did here is add a screen transform. So create an orthographic camera, full frame region, and then add a screen transform. And on that add a screen image and a screen text. And that's all it is to that. And it will simply then trigger these screens to pop up over the whole game. Yeah, so what else? I think that's already it for the character controller, so nothing too crazy here, just also a standard lerp effect that we would have with the cars, or standard movement effect here. Also making sure that the player can't just tap all the time on the screen and the player will just move super fast, but we do have this kind of is moving trigger here. So if the player taps, it will begin move, and then it will be set to is moving, and only once it's done moving, then the player tap will be recognized again. Yeah, so something else that is important is the way that we actually register the click on the screen. So we do that by a behavior script, and those are quite handy. So this one is called alternative movement, and all you need to do to add a behavior script is add component behavior script, so like this. And it's essentially an easy way to kind of recognize certain things. So you always have some kind of trigger like a touch event, or on the start of the scene, on update, or when the distance between two objects is at a certain value. So essentially something very similar we also did within our normal scripts. So maybe you could even create this whole game using behavior scripts. And so in this case, we have a touch start event. So when we start touching on the screen, then we want to call an object API, and this is going to be a script or component. So then essentially I dragged in just the character in here, said call function, and then I chose the function move forward, so the name of move forward, which is also what we exposed here in our script API. And then basically anytime we click on the screen, it will trigger this begin move function. And so that's how kind of the character is moving. All right, and the final bit of logic that we're going to take a look at is the place all objects logic. So this once again is simply attached to an empty scene object that I created and just dragged the script onto it. And so after creating essentially all of the AR scene, I also wanted the player to be able to decide where that AR scene should essentially be placed. So you can see that we have the orthographic camera, which is only responsible for the UI, as well as the character, the streets, and our other game logic here inside of the AR scene object. And now these are already in the scene, but if we're going to take a look at our place all object logic, we do have a subscription here to an event, which is the on start event, which is essentially the same thing as going into a behavior script for the on start event. And so on start, what we want to do is we want to essentially disable the target object, and the target object would then be the AR scene as a whole. So it's simply going to be disabled, which means also that no logic is running. And then we're going to essentially check whether we do have the tracking mode set to world and device tracking is enabled, just as a little security fallback here. And then essentially on start, so if we have a touch start event, we do have the on touch start. And this one is essentially then bringing event data, which will also include the position where we're actually going to tap with our finger or click with our mouse. And all we then do is essentially get the touch position. So with this get touch position method from the event data. And then we are going to send a raycast, which is pretty much like sending a little laser beam into the 3D world from the position where your finger hit the screen. And if we hit something which would be the world mesh that we looked at in the beginning, we are going to very easily place our whole AR scene and enable it so that it somehow seems like it would just pop out of nowhere for the player. And that's a very essential place AR logic. And of course, we also want to then store whether we already have placed, so that if the player then touches the screen again, we do not change the position once more. And that's actually a very simple placing AR object script, which can also be probably used for a lot of other different purposes. All right, but that's it for this video. So I hope you learned something. I hope you found it useful. And as always, thanks a lot for watching and see you next time.